Hey, welcome to another video. This time I'm going to be solving a given differential equation subject to some initial conditions using the variation of parameters method, which basically can be used, the variation of parameters method can be used to solve linear, non-homogeneous differential equations with constant coefficients. So we're going to first find the auxiliary equation, find the complementary function from the auxiliary equation, and then whenever we have a non-homogeneous equation, it means that the differential equation is equal to some function. So we're going to find the particular solutions of the differential equation using that function, and then combine them together, and then plug in the initial conditions to find the constants C1 and C2, and then, or up to C sub n, and then we'll have the solution to the differential equation. So the differential equation that we're going to be solving is y double prime plus 2y prime plus, minus 8y equals 2e to the minus 2x minus e to the minus x. So this part here, that's g of x. That's what makes it non-homogeneous. If this were equal to 0, then that would be homogeneous. But this is the part of the function that will give us the particular solutions. But we're going to start off in part A, which is finding the complementary function. And we find the complementary function by setting the auxiliary equation equal to 0 and then solving for m. So wherever you see a prime, then that's going to be an m. Where you see just the variable by itself, it's going to be m equals 1. So now we factor this. We can factor it into m plus 4, and m minus 2 equals 0. Because that's m squared minus 2m plus 4m plus or minus 8. So that is how it factors. So m sub 1 is minus 4, and m sub 2 is 2, meaning that the complementary function is equal to c1 e to the minus 4x plus c2 e to the 2x. For convenience sake, let's go ahead and label y1 equals e to the minus 4x, and y2 equals e to the 2x. It's good practice to do that, that way you have it for later on. Part B is to find the Wronskian of those functions. So e to the minus 4x, and then e to the 2x. The derivative of e to the minus 4x is minus 4e to the minus 4x. The derivative of e to the 2x is 2e to the 2x. Now with the Wronskian, it's e to the minus 4x times 2e to the 2x minus e to the 2x times minus 4e to the minus 4x. Multiplying these together, we have 2e to the minus 2x because we simply add the exponents of the e's, and then we have plus 4e to the minus 2x. So that turns out to be 6e to the minus 2x, and we're going to need this value, so I'm going to put it in a box. Next we find the Wronskian 1, and the Wronskian 1, you replace the first column with 0 f of x, where f of x equals the right hand side of the given differential equation, which is 2e to the minus 2x minus e to the minus x. And then the second column is y2 and its derivative, e to the 2x, 2e to the 2x. So this one is going to be 0 times 2e to the 2x minus e to the 2x times 2e to the minus 2x minus e to the minus x, which turns out to be minus 2e to the 0, which is just 1. and then plus e to the x. So I'm just going to flip it around, e to the x minus 2. That's the Wronskian one. Before I make a really dumb mistake, I just want to check and mentally see if that's correct. So minus 2, and then the exponents add. So that is 0. So that is going to be minus 2, and then negative and negative makes it positive. E to the 2x plus minus x is just e to the x, so that is correct. So Wronskian 2 is going to be equal to e to the minus 4x, and that's minus 4e to the minus 4x, and then 0, 2e to the minus 2x, minus e to the minus x. And now the second term is going to be multiplied by 0, so we don't have to worry about that. So it's just e to the minus 4x multiplied by 2e to the minus 2x minus e to the minus x. Multiplying this through, we have 2e to the minus 6x, and then minus e to the minus 5x. And that is going to be W2, not the tax form. Then part C is when we find the u's. So u1 is equal to the integral of w1 over w dx, which is going to turn out to be w1 is e to the x minus 2, and then w is 6e to the minus 2x dx. So we can try a let's try splitting up this integral into two different quotients. So we have e to the x over 6e to the minus 2x minus 2 over 6e to the minus 2x dx for both of those. So this first one is going to turn out to be the minus 2x is going to move to the top, and then we multiply those together, which means we add the exponents, which means it's going to be e to the 3x over 6. So e to the 3x over 6 minus 1, well, I'm just going to say e to the 2x over 3 dx. And then if we split these two integrals up, so that way we can move them, deal with them individually, that means that I can do a u sub for both. And if I let u equal 3x here, du over 3 equals dx. And then if I let u equal 2x here, du over 2 equals dx, which means these two are going to equal 1 times 1 over 3 times 1 over 6 is 1 over 18, and then e to the 3x over 18. That's a really bad x. E to the 3x over 18 minus e to the 2x over 6. And now all we have to do is save this u1, because we are going to use this u1 to multiply it by y1 later on. So now u2 is going to equal the integral of w2 over w dx, where w2 equals 2e to the minus 6x minus e to the minus 5x over w, which is 6e minus 2x dx. And again, we're going to go ahead and split these integrals up. So we have the integral of 2e to the 2x over, I'm going to flip these right now. So as you can see, minus 6 and minus 2, those are going to flip, and it's going to be 2e to the 2x over 6e to the 6x dx minus the integral of e to the 2x over 6e to the 5x dx. Now this e to the 2x goes away, this 6x gets replaced with e to the 4x, e to the 2x goes away, e to the 5x gets replaced with e to the 3x, and now we can rewrite these in terms, also this and this goes 1 to 3, and that stays the same. So it's going to be 1/3 the integral of e to the minus 4x dx minus 1/6 the integral of e to the minus 3x dx. Now if we let u equal negative 4x, du over negative du over 4 equals dx, u equals negative 3x, then negative du over 3 equals dx, and then we can do these u subs in our head. So 1/3 times negative 1/4 is negative 1/12 e to the minus 4x, and then we have minus 1/6 times negative 1/3, which is positive 1 over 18 e to the minus 3x, and that is u2. So now step D, we're going to write the particular solution, which is u1 times y1. u1 is this number right here, u1 times y1, which is e to the minus 4x, and then it's plus u2, which is this number right here, multiplied by y2, which is e to the 2x. And now we distribute everything out. So e to the minus 4x times e to the 3x, we're going to add the exponents together, so we're simply going to have e to the minus x over 18. So I'm just going to write 1 over 18 e to the x. E to the minus 4x times e to the 2x is going to be e to the minus 2x, so I'm going to write 1 over 6 e to the 2x plus. That's actually going to be a negative, so I'm going to just go ahead and write negative here. E to the minus 4x times e to the 2x is e to the minus 4x, so it's minus 1 over 12 e to the 2x. And then plus 1 over 18 e to the x, because the negative 3x and the positive 2x add to equal e to the negative x, so it's going to go to the denominator. So can we combine anything here? We can. So that's going to be 1 over 9 e to the x minus 1 over 6 minus 1 over 12 is going to equal 2 over 12 minus 1 over 12, but it's negative 2 over 12 minus 1 over 12 is minus 3 over 12, which equals 1 over 4. So it's minus 1 over 4 e to the 2x. And that is the particular solution. So now part E is going to be y equals the complementary function c1 e to the minus 4x plus c2 e to the 2x plus the particular solution, which is this right here. Duplicate, bring down, and that is the general solution. But now we have to plug in the initial conditions. And I didn't even include the initial conditions up at the beginning here. I was simply focused on writing everything down. The initial conditions are y of 0 equals 1 and y prime of 0 equals 0. I'm going to go ahead and obviously rewrite them down here. So y of 0 equals 0. No, I'm sorry, that's y of 0 equals 1. So we set y equal to 1, and then we have c1 times e to the negative 4 times 0, which is just c1, plus c2, plus 1 over 9, minus 1 over 4. Now, if we add 1 over 9 and 1 over 4 together, the common factor between those is 36. So we have 4 over 36 minus 9 over 36, which is minus 5 over 36. If we add 5 over 36 to both sides, we have 36 over 36 plus 5 over 36, which is 41 over 36. And then we're going to say solve for C1. So C1 is 41 over 36 minus C2. Now, if we differentiate y right now, then we can just plug in C1 afterwards. So y prime is equal to minus 4 C1 e to the minus 4x plus 2c2 e to the 2x, and then the integral, I'm sorry, not the integral, 1 over 9 e to the minus x over 9 is minus 1 over 9 e to the x, and then minus 1 over 4 e to the minus 2x. e to the minus 2x over 4. That's going to be negative 2 is going to come out to the front, which means it's going to be positive 1/2 e to the 2x. And that is going to be the derivative. So now let's plug in C1 here. It is going to be minus 4 times C1, which is 41 over 36, minus C2, e to the minus 4x, plus 2 C2, e to the 2x, minus 1 over 9 e to the x, plus 1/2 e to the 2x. And we can factor this, or we can distribute this negative 4. So that is going to distribute, and so it's going to be negative 41 over 9 plus 4c2 e to the minus 4x, which by the way is still in these parentheses there, plus, I'm going to copy and paste the rest of this down here. Okay. Now we plug in the second initial condition, which is y prime of 0 equals 0. Now when we let y prime equals 0, we have 0 equals e to the minus 4x becomes 1, so it's just minus 41 over 9 plus 4c2 e to the 2x becomes 1 plus 2c2 minus 1 over 9 plus 1/2. And now we can add everything together, solve for c2. So I'm going to say that minus 1 over 9 minus 41 over 9 equals minus 42 over 9 plus 1/2. The common factor between those two is 18. So minus 42 becomes minus 84 over 18 plus 9 over 18 is minus 75 over 18. And then we add that. So it's going to be positive 75 over 18. 75 over 18 equals 4c2 plus 2c2 equals 6c2. Dividing by 6 on both sides gives us that c2 equals 75 over 18 times 6, which is 9 times 12, which is 108. Is there any common factors between those two? Well, there could be a 3. 3 divided 108 divided by 3 is 36, and then it goes into 75. 25 over 36. And I am feeling like there's another common factor between those two, but I'm going to use my calculator just to verify. Nope, 25 over 36. So now we come back up to this first equation here. We plug this in. So 41 over 36 minus 25 over 36 equals 16 over 36, because 40 minus 25 is 15. So 41 minus 25 is 16 over 36. And the common factor here is 4. So it's 4 over 9. So that's C1. So now, step F is simply to rewrite the general equation with C1 and C2 replaced. So y equals C1, which is 4 over 9, e to the minus 4x, plus 25 over 36, e to the 2x, plus the particular solution, which is this right here, 1 over 9x minus 1 over 4 e to the 2x. That's positive, yeah. And that is the final answer. So let me go ahead and give that a quick check in the back of the book. I already checked it in the beginning just to make sure that I was on the right track, so I'm pretty confident that that's the right answer. But there might be an arithmetic error here and there. So number 21, y equals 4 over 9 e to the minus 4x plus 25 over 36 e to the 2x minus 1 over 4 e to the minus 2x plus 1 over 9 e to the minus x. So that's the final answer. If you watched all the way up to here, I appreciate you. Thank you for watching, and I hope this video helped. Have a good night.